So it gives me great pleasure to introduce our next speaker. Our next speaker is Michael Bobotis. He's with Hatch. And we've been talking to Michael about just putting together a storyline around decarbonization in Ontario, decarbonization in the mining industry, and really trying to rally ourselves around a common understanding on why we need to decarbonize and sort of what are the opportunities, and to really get a good taste of what the lay of the land is like in the areas around decarbonization. What does it mean? What can we do about it? What's being done about it? And also to give us some numbers, so that we can understand the scale of the opportunity, and also that we can understand, what Canada, needs to do to play a role in the decarbonization space. And, we as MICA, we're all about enabling technologies. So we want to be able to identify enabling technologies that can help our industry to decarbonize. But we know that in that process, we're going to create jobs, opportunities for Canadians. So for us, decarbonization is not only the right thing to do, but it's also an opportunity for Canadians to, play a leading role globally in how the mining industry addresses decarbonization, et cetera. So, Michael, please come on over and inform us of what we need to know.
All right. Good afternoon, everyone. Before I came up here, Charles gave me the very succinct challenge: decarbonize the world now. Whoa. Okay, no easy feat, Charles, but I'll try my best. So thanks, everybody, for joining and attending this innovation conference. Innovation is not something I normally deal with. As most of you probably know, I'm part of Hatch, and Hatch is a consulting firm that is part engineering consulting firm, part full EPCM contractor. So a lot of you in the room have probably worked with Hatch at some point or another. Okay, so let's get started. I think a lot of the points that I wanted to address today have been addressed probably more eloquently than I can over the course of the last couple of days, but I'll touch on some of the points that Charles brought up, and then touch upon really what are the actions that need to be done by the industry at the tail end of all this, and it's no easy task. So Ontario mining, I think it was very eloquently put by, I believe his name was Stephen, the VP of Sustainability from Wailu. At the end of the day, critical minerals are the energy transition foundation. And to produce that, to extract that, to circulate and reuse, recycle these minerals are key to the energy transition, and it's not going to be an easy task to get there, to close the gap on that shortfall between supply and demand. Now, everybody has a different take on what supply might look like between now and, let's say, 2030, 2035, but I think everybody's in agreement that minerals like copper, nickel, and cobalt, they will be on the rise in terms of demand. Now, whether Canada or whether the world can actually meet the supply of these minerals, that's critical to the whole discussion. And more importantly, can we meet that increased demand and decarbonize mining operations and explore other ventures like deep mining and recycling? These are very big topics. So Ontario in of itself is positioning itself to become a global player in critical minerals supply chains. It was put very eloquently early on. We're not going to be able to do the whole thing ourselves in terms of delivering these critical minerals in end states to actually be used. We're going to still be relying on China and other countries to actually take some of these minerals, refine and process, get them to end states to actually be usable. But ideally, the best way to decarbonize an industry is self-reliance in terms of having the whole value chain localized. And again, very, very tall order. Goes beyond innovation. At that point, it just becomes an issue of funding, and a lot of funding. So Ontario the good news is that we do have quite a bit of mine production value at the moment, and our assets, not just in Ontario, but in all of Canada, are some of the biggest and best and most sustainable assets in the world. Some might argue with that point, but by and large, our carbon intensity, depending on the type of operation we're talking about, is either quite low, in some cases quite high, but overall quite good. And we're projected to increase that value quite substantially when it comes to critical minerals between now and 2030. The graph that I have on the left there is a very, let's call it, pessimistic projection of how production value could increase. So the problem statement. So Ontario mining emissions have been rising since 2005, and I'll show later that's despite the fact that Ontario's grid has become very, very clean. And the main reason for that I'll also touch upon in a minute. But really, the long and short of it is that Ontario's climate change policies, they're helping, but are they targeted enough? Is there enough funding being put into the mining projects? To a certain extent, yes. To a certain extent, no. And at the end of the day, is that funding being directed at technologies themselves in terms of innovation, commercialization, and adoption? Not for me to answer, but it is an ongoing problem. There's a gap that's projected. And again, this forecast that I'm showing here at the top, that is a very optimistic forecast, depending on exactly how many new projects get turned online. And as you can see, there's an Ontario 2030 target for emissions in the sector and how mining can contribute to that, and a Canadian one as well. And you can see that there's a pretty significant gap between what could be forecasted, depending on, even if we look at this very asymptotic relationship of forecast versus Ontario versus the provincial and Canadian targets. So critical minerals, 30% of Ontario mines would produce critical minerals, and that should increase within the next 10 to 20 years. Some of the projects, some of the folks that are in charge of projects, greenfield projects in this room, are keenly aware of that, Wailu being a great example of that with Eagle's Nest Ring of Fire project. So now it's a question of figuring out what are direct emissions, indirect emissions within mining, how do we target those very specifically in order to actually achieve some form of GHG reduction. And that does come down to accelerating technology readiness, accelerating commercial readiness, and arguably more importantly, accelerating adoption, which is arguably the biggest challenge the mining sector is facing at the moment. So sort of ignoring Scope 3 emissions for the time being, even though Scope 3 emissions and for anybody who isn't familiar with the terminology of Scope 1, Scope 2, Scope 3, Scope 1 is direct emissions from an operating source, such as the burning of fossil fuels at a site. Scope 2 emissions is emissions that are indirect from electricity usage. And Scope 3 is basically everything else. And Scope 3, arguably, mining has one of the biggest challenges in the industry, which is Scope 3. Why? Because a lot of other industries are dependent on us to reduce their Scope 3 emissions, and we, in turn, are reliant on a lot of other industries and sectors to actually reduce Scope 3 emissions. So monitoring of that and transparent monitoring that is very important at this stage. And right now, to meet 2030 targets, we have to look at Scope 1 and Scope 2 emissions. So as I alluded to earlier, Ontario has a fairly clean grid. Again, some might argue exactly how clean nuclear energy might be, but that's a debate left for another time. At the end of the day, if you're looking at sheer carbon intensity, Ontario is ahead of the curve when it comes to its projections there. Now, whether it can increase its capacity is a whole other matter. That's something, again, up for debate and is going to be an ongoing challenge to enable new projects to actually turn online within Ontario. But now the main challenge is really twofold. Scope 1 emissions, how do we get rid of fossil fuels? And 2, how do we try to not depend on a grid as much as we possibly can? And the main reason for that, again, ties back to is the grid actually reliable enough to supply that power? And are you actually going to have grid power in some locations in Northern Ontario for construction activities? Construction activities during the mining phase or the mining project life cycle can be one of the most carbon intensive. And the problem with that is that you're not likely going to have access to grid power in Northern Ontario during that phase of a project. So you have to look at on-site generation of ideally renewable energy. And that's going to be part of the challenge, is just the sheer capital-intensive nature of that, of getting that type of system set up, is going to be very tricky to pull off, especially in the near future. So, prominent challenges, which I've already been sort of alluding to as we go along. The biggest challenge, again, is renewable energy sourcing. So in the event that for X and Y reasons, the national grid or the provincial grid can't supply the power, can't supply the power in time during the most carbon-intensive portions of the project life cycle, what do? You go to on-site renewable energy sourcing and storage. And what do these solutions look like at the moment? It's a mixture of everything you're seeing on the left-hand side there. It's solar, it's wind generation, and arguably nuclear. Now, the problem is that you need to get these energy sources to be as scalable, and at the moment, the only viable solutions out there truly in terms of either providing all energy on site or at least providing backup energy generation in terms of being at least partially renewable, is it being a hybrid solution. And a hybrid solution, it will get you some, at least part of the way in terms of potentially getting a return on investment on that upfront capex. Why? Because the more you try to increase your renewable penetration, so if you try to have it all solar, all wind, or half solar, half wind, there is that huge issue of having to store that energy because you're not going to have access year-round to solar. You're not going to have year-round access to wind. And hydro is also could be part of the mix, but there's a scalability issue with hydro and a geographical issue with hydro. So if you're talking remote operations that need a lot of power, then you're going to go with a hybrid solution. You're going to go with biomass. You're going to go with likely some form of fossil fuel backup generation, just to make sure that you can keep your electricity costs at the mine as low as they can possibly be. Hopefully that will change in the coming decades, where it will make sense. It will be a viable solution to have 100% renewables. Of course, there's small nuclear modular reactors that are out in the mix, but again, it's a whole other debate. But I just threw it out there for those that are aware of it and are aware of the problem statement and getting that kind of ready for the mining industry. Equipment electrification is something that is arguably very advanced, depending on its application and depending on the type and size of vehicle we're talking about. So underground mining, it's there. There's a lot of equipment that's electrified either via cable or via battery. The issue is application. So there's been a lot of forward momentum and positive forward momentum in coming up with change management processes for legacy mines that want to integrate electric equipment. Now, the problem is that electric equipment, there's two issues, really. One is that change management component. So how do you get the people at a mine to upskill and maintain these equipment? And the other issue, unfortunately, is high total cost of ownership. It's preventing its full adoption across the industry, and the only way it's viable in an underground mine setting at the moment is if you're mining in very, very deep mines, where you need to somehow reduce your fossil fuel usage to reduce your heat generation and get a mine to actually be potentially viable if you can reduce your ventilation requirements. But again, that works better for greenfield operations than it does for brownfield operations, where you've already put your upfront capital into your ventilation infrastructure. So improving batteries, making sure that they can be deployed in as operationally undisruptive, to use a not so fancy word, as possible, is a focus of the industry and has to be a continuing focus of the industry. Fuel switching. Fuel switching is, there's a lot of momentum there, and there's a lot of challenges there as well. One of the biggest challenges is getting hydrogen to penetrate more into the mining sector. It's not going to happen anytime soon for a number of different reasons. It'll have its use cases, and those use cases will grow with time, but it's a chicken or the egg issue. The chicken or the egg issue is it needs to be at a price that's at least comparable to fossil fuels, which it won't be for quite a while, not until production and distribution becomes more localized and actually starts to make a hell of a lot more sense. Plus, producing hydrogen is very energy intensive. So other emerging fuels like very specifically renewable diesel, which I still, for some reason, get a lot of questions on what renewable diesel is to this day, even though I'd have thought by now that a lot of people would have gotten very sensitized to what renewable diesel is. Renewable diesel is, in theory, a magical fuel simply because it has extremely low life cycle emissions. It's sort of the same process as producing biodiesel, but it's instead of esterification, I believe. I think it's a hydrotreatment process using very similar feedstocks as how you produce biodiesel. And what comes out is a diesel that is essentially a plug and play with petroleum diesel. It essentially acts the same way. In fact, there's some tests that have shown that cetane ratings can be higher energy densities. Sometimes you hear that as well. But the long story short is that it is 100% plug and play diesel that can be stored the same as petroleum diesel, has all the same characteristics as petroleum diesel. Now, the issue with renewable diesel is limited production. And where do you get that feedstock? And that is a huge, huge issue because feedstock could be agricultural, could be waste, could be a number of different sources, but scaling that feedstock is going to become a real challenge. And it's not necessarily a mining challenge. This is a cross-sectoral challenge because renewable diesel is, unfortunately, one of the only ways that a lot of industries out there are going to be able to decarbonize. I'm referring specifically to aviation. Aviation has no choice but to go with, I don't think they call it renewable diesel, and I think they call it something else, something aviation fuel, but it's essentially renewable diesel. So the other thing about mines and what has to be focused on a great deal, and again, adoption is going to be a huge challenge, is digitalization and automation. I say digitalization because it is just another subset of digital, but with a slightly more enhanced meaning. It really is just bringing more Industry 4.0 technologies into the mining world, which some presentations we saw today, I'm glad to see that, AI, machine learning, a lot of these types of processes are starting to actually be looked at and hopefully integrated into more and more mines. One of the main issues and barriers towards some of these digitalization systems is, of course, people don't understand them. They're not exactly turnkey. There's a fairly long adoption curve to get them to work and work properly at a mine and to actually be able to use them effectively for decision making. And the other, of course, is if you want, for instance, autonomous mining to work and have, a lot of data being monitored and recorded and analyzed, that presupposes you have a very sophisticated telecommunication system set up in an underground mine, which is very difficult to pull off and very costly. Process and product circularity has to be a focus. So, there's subaqueous mining, there's deep sea mining that has to be looked at. There's no doubt about that. Anything that's an alternative to simply just the way we do things in terms of open pit or underground mining, those have to be looked at, and that includes taking existing products that are just not being used and recycling them, and introducing innovations within the mining operation that look at reducing and reusing water, because that is a huge issue in certain parts of the world. Is that okay? Still working. So water treatment, chemical usage, pumping efficiency has to be looked at, reusing and recycling water, extending the life of existing minerals, all has to be very much top of mind. And now the biggest challenge that the industry is facing is skill shortage and change management procedures. So if a technology has been matured and is fairly well understood by a specific company, great. How do you get critical mass in terms of its adoption? That's the predominant challenge that the industry is facing at the moment. I don't have any easy solutions at the moment. I just laying out the problem, and of course trying to figure out how to address this. The change management procedure side of things is also very, very has to be looked at in greater detail. So I'll kind of transition to a couple of concluding slides, but really what I want to say here, and I usually start some of these presentations with this slide, but I thought maybe more end the presentation with this type of slide. The one thing that I want innovation to focus on is not just decarbonization as the end goal. It has to be about a plethora of pillars that have to be kind of looked at. Increased productivity, making sure that health and safety are improved at a mine, of course, economies of scale, trying to improve that and lowering operating costs. All of that has to be really, really looked at. And through the foundations and ecosystems like MICA, come up with some ways of having innovative financing to kind of push forward a technology and commercialize it, and make sure that even if it acts as an awareness piece and really drives that need to adopt, that does wonders, especially in an industry like the mining sector, which is so risk averse. So the call to action really comes down to focusing on these key solutions that are in different levels of maturity, whether at the technological level or commercial level. But ideally, what we want to see in the short term to achieve 2030 targets, you want hybrid energy generation to become more and more of a reality at mine sites. And that is slowly happening. Digital systems integration, so having companies that are out there that are pushing the envelope in terms of what can be done in terms of digitalization, increase electrification, so coming up with ways to try and make that business case make more sense. That's part and parcel with kind of two factors. One is the actual equipment has to make sense from a costing perspective, and that's on the OEMs to figure out. And on the other end, of course, is how to integrate it viably within an operation. So making sure that it's as minimally disruptive as possible, because unfortunately, mobile equipment that use batteries, they're relying on battery module or modules that have limited energy density. So trying to figure out how to integrate them viably into a mining operation is very, very important. And of course, more fuel switching. And in terms of long-term decarbonization solutions, getting technologies that are maybe not yet commercially ready to be scalable and achieve 100% renewable energy generation on site, that can help a lot of different types of operations, especially the operations out there that are very remote and still require a lot of energy. Sustainable human-machine collaboration. So jumping now to Industry 5.0, I can probably talk about Industry 5.0 for 30 minutes because that was a recent topic of discussion both within Hatch and some of our collaborators. And then, of course, fully autonomous zero-entry mining. So ideally, what you want to see between now and, let's say, 2040, 2050 is more operations where you have essentially no one on site. That is one of the ideals that you want to achieve. And, of course, within all of this, if electrification, fuel switching, if renewable energy cannot be better brought to site, then at least have some form of carbon capture on site be done effectively and viably should be a focus. Now, Scope 3, or let's call it miscellaneous life cycle emissions, has to be a focus as well, whether that's a good venue within MICA or is should be more of a focus outside of the mining sector itself. I mean, you can kind of cross-pollinate between different sectors when it comes to these topics, but we need to have equipment. The problem with equipment, and I think it was, I had a discussion with Doug Morrison about this last week, and he basically, he put it fairly eloquently. We're putting more energy into moving machinery than we are into moving payload. Payload meaning actual mine material. And that's true. That's true. It's very big machinery that is very heavy and requires a lot of energy to move. So trying to come up with more durable materials that are lighter should be a focus for all industries. And also to ease the logistical nightmare of bringing parts to site, having 3D printing on-site manufacturing should be a focus as well. And again, to tie back to what I said earlier about circularity, recycling, reducing waste and water, or reusing water, all very, very important. So if there's one key takeaway that I want you to have from this particular presentation is decarbonization should be a focus for the industry, but it should not be looked at in a singular lens. It has to be, you have to look at decarbonization within the context of trying to also improve operational productivities, trying to lower costs, trying to improve worker health and safety. It has to be, it's that prism that you have to look at decarbonization. And any decarbonization solution that doesn't try to at least address some of these other, let's call it targets for the industry, is doomed to fail, and for good reason. So I'll leave it with that, and thank you everybody for your time. Do I have enough time for questions?
Hopefully mine's really quick. Is Hatch playing a role in the skill gap issue that we're dealing with?
To my knowledge, I think what we're trying to do is work with organizations like CIM and GMG to try and figure out how to have more meaningful outreach to universities and other players that, within the, let's call it academic space, to try and figure out if there are ways to kind of get them, excited about mining. And it's an ongoing and tough challenge, but yes, we're involved in those organizations.
Hi, sorry. As an engineering company, Hatch, how do you handle the time of when you are doing the engineering to the time when the project is being built? Because many of these technologies should be considered at the engineering stage to be incorporated in a way more faster or better. For example, in dust control, if you consider dust control measures in the engineering stage, you could reduce up to 50 or 60% of all the dust emissions of the mine site. So how do you handle this incorporation of new technologies in the engineering stage of greenfield projects or new projects? And now with the permitting delays that added extra complexity?
Yeah, it's not an easy question, but the long story short on that one is what we try to do is, well, first of all, Hatch prides itself on being technology agnostic. We don't have a specific vendor that we normally partner with. It's all on a per project basis, what we feel is best for the project in order to achieve its many different targets. The problem is that if you want to incorporate innovation or an emerging technology, it's going to be very difficult to incorporate it in a way so that you can accelerate it within the development of the project, and also make sure that it gets on time via, in terms of permitting targets, in terms of other targets. What we try to do is we try to work with specific partners that maybe have lower technology readiness, and try to figure out how to work with them in a very targeted manner to try and accelerate that readiness level and make it so that we can get a pilot going at a specific project if we feel it has actual legs to stand on. So that technology, for instance, could be, I'll come with an example, something like Blue Vein. Blue Vein is a technology that is out there and that is embedded within the Australian mining sphere, because it is an AusMine collaboration with a number of different private industry partners like BHP and so forth. But they don't have a proper pilot at an operation ongoing yet. But there are some customers out there that would like to incorporate that in. And a company like Blue Vein would love to work with a Hatch to try and accelerate, getting that type of pilot going at an operation. And then we right-size both the client and the vendor themselves, in this case Blue Vein, to try and say, look, yes, we can try and get that technology to work and work at the operation, but let's be real about the amount of specialized engineering and the amount of skills that you're going to need to field engineering to actually get this deployed at a site. So it's tough, but we do these types of collaborations, and thankfully we do them successfully where it makes sense.